Hello everyone, and we, the Group 3, will be introducing to you the Haber process, and we will answer the 5 questions. What is the Haber process? How does it work? What does it do? And how can it affect us? And what are the good and bad effects of the Haber process to human and the environment? Haber process is one of the most efficient and successful procedures to being adopted for the production of ammonia. The process combines nitrogen from the air with hydrogen derived mainly from the natural gas methane into ammonia. The reaction is reversible and the production of ammonia is exothermic.
What does it do? The process combines atmospheric nitrogen with hydrogen to produce ammonia, which is a major component of fertilizers used to promote plant growth. The Haber process provides a good case study to illustrate how industrial chemists use their knowledge of factors that affect chemical equilibria to find the best conditions needed to produce a good yield of products at a reasonable rate. In a Haber process, the atmospheric nitrogen, N2, is converted to ammonia, NH3, by reacting it with the hydrogen, H2. Here, a metal catalyst is used and the high temperatures and pressures are maintained. How does it work? The process works today much like it originally did by using extremely high pressure to force a chemical reaction. It works by fixing nitrogen from the air with hydrogen from natural gas to produce ammonia. The Haber-Bosch process uses a catalyst or container made of iron or ruthenium with an inside temperature of over 800 Fahrenheit and a pressure of around 200 atmospheres to force nitrogen and hydrogen together. The fluid ammonia is then used to create fertilizers. Today, chemical fertilizers contribute to about half of nitrogen put into global agriculture, and this number is higher in developing countries.
How can it affect us? Ammonia was in high demand for fertilizer across the globe. Although nitrogen is highly abundant, forming almost 80% of the air around us, it is an extremely stable gas and does not readily react with other chemicals. Converting N2 into ammonia poses a challenge for chemists globally. The Haber-Bosch process, named after its German inventors Fritz Haber and Karl Bosch, was able to produce ammonia on a large scale at a higher efficiency than ever before. The process was groundbreaking, and the duo earned 2 Nobel Prizes in 1918 and 1931 for their work on a large-scale chemical processes. The Haber process has also contributed to problems in the environment, many of which affects us today, and which we have to face the direct consequences of. For example, the Haber process uses tons of energy, consuming around 1 to 2% of the world's energy supply. It also contributes to a build-up of reactive nitrogen in the biosphere, causing potential harm to the nitrogen cycle, as well as this runoff from the very popular nitrogen fertilizers can disrupt biological habitats with nitrates leaching into rivers, ponds, and lakes, alongside expanding dead zones in oceans and affecting natural ecosystems. It is now the third most important greenhouse gas, only succeeded by carbon dioxide and methane. Now, let us know the good and bad effects of the Haber process. The process allows us to use the extensive amount of nitrogen available in the atmosphere. Second, the end product of the process has fed and continues to help feed more than half of the global population. I'll explain that after we have a look at how plants prepare food and why nitrogen is essential for the process. The current process of nitrogen fixation is also not completely efficient, and a large amount is lost after it is applied to fields due to runoff when it rains, and not a natural gassing off as it sits in fields. Its creation is also extremely energy intensive due to high temperature pressure needed to break nitrogen's molecular bonds. Scientists are currently working to develop more efficient ways to complete the process and to create more environmentally friendly ways to support the world's agriculture and growing population.
That is it, folks. Thanks for watching, and we do hope that you learned something from us.